At first glance, the blueprint looked like ambition made visible. Inside the Space Shuttle's cargo bay sat a giant Centaur upper stage, a hydrogen-fueled rocket powerful enough to send spacecraft far beyond Earth. Planetary missions depended on performance like this. Mission planners saw reach, engineers saw capability. The Shuttle-Centaur concept promised something NASA had wanted for years, a way to turn the shuttle into the starting point for deep space exploration. From that perspective, the question seemed straightforward. Could NASA make it work? The answer appeared to be yes. Centaur was not an experimental fantasy. It already had a successful history. The rocket had proven it could perform demanding missions. NASA continued investing in the shuttle version. Exploration plans were being built around it. Confidence was not difficult to find. The image looked compelling. A shuttle lifting from the launch pad carrying astronauts in the front and a powerful upper stage behind them. One vehicle, one launch, a direct path towards some of the most ambitious missions on the drawing board. The cargo bay blueprint represented possibility. Then the blueprint became reality. As engineers translated concepts into hardware, the vehicle inside the drawings became more specific. Tanks, plumbing, vent lines, interfaces, procedures, requirements. The Centaur stage carried liquid hydrogen and liquid oxygen. That was part of its value. Those propellants delivered extraordinary performance. They also created operating conditions unlike those of ordinary shuttle payloads. The shuttle was no longer carrying a passive spacecraft. It was carrying a large cryogenic rocket stage with its own needs, its own behaviors, and its own failure scenarios. The closer the design moved toward implementation, the more visible those realities became. Integration drawings filled with systems dedicated to managing temperature, pressure, venting, and containment. The challenge no longer looked like fitting a payload inside a cargo bay. The payload was changing the character of the cargo bay itself. Yet this still looked like an engineering problem. And engineering problems were supposed to have engineering solutions. So the work continued. A concern appeared. A mitigation followed. Another concern appeared. Another mitigation followed. Hydrogen management generated questions. Venting generated questions. Abort scenarios generated questions. The pattern became increasingly difficult to ignore. Every solution seemed to solve the previous argument while creating a new version of the same discussion. The rocket itself remained technically achievable. Confidence did not behave the way confidence was supposed to. Normally, greater understanding produces greater certainty. Here, greater understanding produced additional review marks. The blueprint remained on the table. The annotations multiplied. What made the situation unusual was not that hazards existed. Hazards exist throughout spaceflight. The unusual part was that different groups were beginning to react differently to the same information. Engineers examined the evidence and continued developing solutions. Managers examined the evidence and continued pursuing capability. Astronauts and safety officials examined the evidence and increasingly focused on something else. The assumptions. Not whether the system could function, whether the reasoning used to justify the risk deserved trust. The disagreement was subtle at first. Then it became harder to conceal. The conflict was slowly migrating away from hardware. A hydrogen line could be redesigned. A procedure could be rewritten. A venting sequence could be modified. But who decided when the remaining risk became acceptable? That question had no valve, no switch, and no engineering drawing. The same data now supported multiple conclusions. And once that happens inside a complex organization, technical progress no longer guarantees agreement. The cargo bay blueprint was beginning to represent something different. Not ambition, not complexity, disagreement. Then the environment around the debate changed. In January of 1986, Challenger was lost. The disaster did not directly answer every question surrounding Shuttle-Centaur. It did something more important. It changed the standard by which questions were judged. Assumptions that previously seemed acceptable were re-examined. Risk logic that once appeared reasonable received new scrutiny. Across NASA, confidence in institutional decision-making became a subject of investigation. The Shuttle-Centaur program now faced a problem that engineering work alone could not solve. It had been designed for one environment. It was being judged in another. The hardware had not suddenly become different. The framework used to evaluate the hardware had. That distinction mattered. Because Shuttle-Centaur's strongest argument had always been capability, its weakest argument was becoming confidence. Reviews continued. Analyses continued. The vehicle itself did not collapse under technical failure. The deeper issue was that understanding kept improving while agreement kept shrinking. If engineering fixes were sufficient, confidence should have risen. Instead, confidence continued draining away. The contradiction became impossible to miss. NASA still wanted what Centaur offered. Planetary missions still benefited from its performance. The exploration logic remained largely intact. But legitimacy was eroding. The people evaluating the risk no longer shared a common answer to a basic question. What level of danger was acceptable for a crewed shuttle? No equation could settle that completely. No test could remove the human judgment hidden inside the decision. The debate had become a dispute over ownership of risk. Who had the authority to define acceptable? Who had the responsibility to live with the consequences? And what happens when those answers belong to different people? Eventually, the outcome arrived. Not as an explosion. Not as a launch. Not as a failed mission. As a decision. NASA canceled Shuttle-Centaur. The giant hydrogen-fueled stage never flew inside the shuttle. The capability remained real. The need remained real. What disappeared was confidence. And that is what makes the story unusual. Many spaceflight stories are driven by catastrophe. This one is driven by the absence of catastrophe. A system survived technical scrutiny long enough to reveal a different vulnerability. Trust. Look again at that cargo bay blueprint. At the beginning, it represented the future NASA hoped to build. A shuttle carrying the power needed to push exploration farther into the solar system. Then the drawing accumulated requirements. Then reviews. Then questions. Then disagreements. Finally, the concept itself was crossed out. Not because the rocket proved it could not work. Not because the missions no longer mattered. But because confidence reached zero before capability did. The most ambitious shuttle payload never flew. In the end, the rocket was not canceled by a technical failure. It was canceled by the collapse of agreement over who should be asked to trust it.